Alright, we're going to make a time of LAN video, try to help you do this homework assignment that was apparently due last week. We're going to do number 1 on the homework. 24th of January, 700 zone time, DR position, 22 degrees, 25 minutes north, 46 degrees, 10 minutes west. We need the zone description. 46 degrees, 10 minutes divided by 15 is going to give us a +3 zone description. Your vessel's on a course of 110 degrees true. To get that into a course angle, we're going to do 180 minus 110, and that gives us south 70 degrees east. We're at a speed of 12 knots. What is the zone time of local apparent noon? Okay, I've written down all the pertinent information required from this problem so that we can go into the Nautical Almanac and determine MRPAS. Okay, so we're going to go into the Nautical Almanac and we're going to get MRPAS on the 24th of January. So we take the Almanac. Go to the 24th of January. Go down to the lower right-hand page, lower right-hand corner of the right-hand page, and you see MRPAS for the sun. This is the third column, all right? 22nd, 23rd, 24th. 24th of January is 12:12. That 12:12 goes here. And we get the time difference between 12:12 and 0700, which is 4 hours and 12 minutes. We then multiply 4.2 hours times 12 knots, because that's the speed we're going, and that gives us 50.4 nautical miles. Okay, now we're going to determine where our 12:12 DR position is. Okay, one of two ways we can do this. We can either do it by plot, or we can do it by sailing. Now, I don't feel like setting up a plotting sheet, so I'm going to do it by Mercator sailing. Okay, so that's using the navigational right triangle, which I am putting on my page here. Okay, this is the only thing I need to know, and I need to know my so, ka, toa. All right, so I need to find my change of latitude. So my change of latitude is little l. Little l is adjacent to my course angle, and distance is my hypotenuse. So I am concerned with cosine. Okay? So L equals 50.4, that's distance, times the cosine of 70 degrees. That's my course angle. You can also put in 110 degrees. The only difference is that 110 degrees is going to give you a negative number, which is just telling you that you are moving southerly. Okay, when you plug this in to your Casio FX 300 ES Plus, gives me 17.2 nautical miles. South, right? Because course angle is south 70 east. Right? So lat 1 God damn it. Lat 1 is 22, 25 north. Long 1 is 46, 10 west. My change in latitude is 17.2 south. I'm going to use 17 to make the math easier. Okay, and that's going to give me 22, 8 minutes north. Right? I'm at 22 degrees, 25 minutes north. I'm heading east-southeast. All right, so I'm going to subtract that 17 minutes from 25, and that gives me 22 degrees, 8 minutes north. Okay, we're going to figure out our DLO here to get long 2. All right, in order to figure out our DLO, we need to find our meridional parts, which is this M. Okay, so we get our navigational Bible, Bowditch 2, and we find 22 degrees. Where's my eraser? we find 22 degrees. I hope nobody's getting seasick. 22 degrees, 25 minutes. So we got M1, M2, combine those together. Okay, 25, 22, 25, 1371.9. Okay, 22 and 8. 22, 8. 1353.6. Okay, now, look at that, beautiful. Move that out of the way. All right, now, get the time get the difference here, all right? Because why? North and north, difference, right? 9 minus 6 is 3. 11 minus 3 is 8. 6 minus 5 is 1. 13 minus 13 is 0. Now, just to make sure my math is right here, I'm not plugging. Look at that dyslexia. 18.3. 18.3. Sweet. All right. Now, opposite, adjacent, tan. Okay? So, DLO is equal to M, which is 18.3, times the tan of the course. Or course angle. And that gives me 50.3. All right, I'm just going to throw in 50. And we are heading east. Okay, in the Western Hemisphere, heading east, our longitude is going to get smaller. Okay, so that means this is going to be 45 degrees, 20 minutes west. All right, so that's where we're supposed to be at 12:12. Okay, now we're going to take that number and we're going now to determine how we're now going to use this new position. All right, so our 12:12 DR latitude is 22.8 north and longitude 45.20 west. Okay? Now, two methods that I teach that I want you to be able to do. Why? Because I'm an asshole. But it'll make you a better person. So, first method is the DLO method. Also the central meridian method. So, take our central meridian, which is 45 degrees. How do I know that? 15 times 3 is 45. 3 is our zone description. All right. We take our DR longitude, 45, 20 minutes west. We are a total of 20 minutes to the west of our central meridian. Okay? When we're to the west of our meridian, the sun is going to get to us later. Okay? So if we were at the central meridian, Merpass would occur at 12:12. But since we are 20 minutes later, 20 minutes of longitude later, since our position is actually further to the west of our central meridian, the sun is going to get to us after it gets to the central meridian. So we have to convert our DLO into time. Okay? So we convert our DLO into time by converting the DLO itself into degrees. So I'm going to take 20 minutes, divide that by 60, and I'm going to multiply that by 4. Why am I multiplying that by 4? Because 1 degree of arc is equal to 4 minutes of time. So that gives me 1 minute, 20 seconds of time. Okay? Now I take, and that's west. Okay, so I'm going to take 1212 over here. I'm going to take 1212, which is the time in word class, and I'm going to add that 1 minute of time, and that gives me 1213. And that is my answer. Okay? Now, that's the DLO method. The local mean time method is very similar to an ETA. Okay, I'm going to take the time of MERPASS, which is 1212. I'm going to figure out I'm going to take the DR longitude that we used, and I'm going to convert that to time. And that gives me 3 degrees, 3 hours, so this here, 3 hours, 1 minute, 20 seconds, west. Okay? So 3 hours, 1 minute, west. Just like in ETA, I'm going to add that, 13, 15, GMT. Zone description is +3, so I'm going back to zone time, so I'm going to subtract that 3, 12, 13. Boom. Boom. And that is one problem. Okay?